Hi, welcome to the demonstration corner. My name's Kelsey, and today we're going to be going over the TPS Slab Anisotropic module. Available on our advanced measurement platform, the MP-1, the Slab Anisotropic module is a new addition to our three-dimensional standard module. So just to give a little bit of background, the three-dimensional anisotropic standard module available in the MP-1 follows ISO 22007-2 for testing bulk anisotropic samples for axial and radial thermal conductivity and thermal diffusivity. As described in the standard, this module requires the input of volumetric specific heat, which can be measured with an additional second measurement using the TPS specific heat module or the DSC. So our new patented 3D slab anisotropic module evolves the TPS method in a few different ways. The first one is that it improves anisotropic testing on thinner samples between 0.3 and 10 millimeters. The second is that it does not require the input of volumetric specific heat, and actually the three-dimensional slab anisotropic module measures thermal conductivity, thermal diffusivity, and specific heat. So we'll just go through some basic setup of the TPS slab anisotropic module. So here we just have a few different samples that can be measured with the slab anisotropic module. We have an injection molded polymer, compressed fiberglass, and thin mica sheetboard. And today we're going to be testing Duratron for an anisotropic sample. So we're going to connect our TPS sensor to our stand, place a foam on either side of the sample to enforce the boundary condition, and do the exact same thing for a symmetric setup. Then we're just going to place our protective disc, protect the top sample, and clamp it all together, create good contact between the sample and the sensor. Now we can just move over to the software and set up the measurement. Okay, so now that we're in the software, we can set up all the information to run our test. So we'll enter our operator ID and save our results, and select the method to run our test. So this will be a 3D disk source method with the slab anisotropic modifiers. So here we can enter all the information relevant to our sample that we're testing. So we're measuring Duratron with XPS as our backing material. The samples are about 2.5 millimeters thick and have a radius of 12.5 millimeters. The sensor we're using today is the 2117-1 sensor that has a radius of 3.2 millimeters. So we'll check the resistance of our sensor. Okay, so now we can set up a schedule with these parameters. So we're going to be running 5 tests on this sample with a delay of 10 minutes. And we're going to use a test time of 10 seconds and 100 milliwatts. So then we can start our schedule and let our measurements run. So we've already run some tests on this sample, so we can take a look at the results. So here we have our tests run on the same Duratron samples with the same parameters. And if we select all 5 of our test results, we can compare axial conductivity and our radial conductivity, taking a look at our mean and our standard deviation. So that's all there is for running a quick test with the slab anisotropic module. In review, the 3D slab anisotropic was developed to remove the barrier of needing the input of volumetric specific heat, which is often measured by a second method, making this fantastic module much more accessible. We continue to strive for the intelligent MP-1 to be at the apex of thermophysical instrumentation with our patented advancements. If you have any questions or want to see your own application consultation, please contact us at info@thermtest.com or with the information in the description.